Hi everyone, in this video I'm going to talk about how to write the slope-intercept form based on given set of information. In the first case, actually before I get into the first case, I just want to mention that the slope-intercept form is y equals mx plus b. And it would be good to take a moment to just review what the parts of this actually mean. So the most important part of this formula lies here and right there. And actually, to be completely honest, it's just that. The M stands for slope. Now, it's a strange thing. The word slope does not even have the letter M in it. So it might be better to think of slope as a set of directions that cause movement along a line that is created by the function. And so slope actually has to do with the way a line moves or the steepness of a line. So it might make more sense to think of M as standing for the word movement, because the slope is a set of directions that represents the change in y over the change in x. It's a two-step dance. You either go up or down, and then you either go right or left. So this controls vertical movement and this controls horizontal movement. The letter B stands for the y-intercept. So this is usually or always the y-intercept. But again, the y-intercept does not have the letter B in it. So rather than confuse ourselves with this fact, it might be better to think of it in a slightly different way. So the letter B, let's think of this as a place where we begin, because we have to begin at this location. Now the location of the y-intercept will always be given by 0, comma, and some kind of y value. The reason that the first value is 0 is because in order to be a y-intercept, you have to actually be on the y-axis. And so if I were to put any point on the y-axis, like for example this one right here, this would be 0, comma, y. And it would be 0 because this green point is neither to the right nor to the left of the y-axis. It's simply on it. And the y value could be anything, positive, negative, or 0, just like a number line, but standing up. Okay, so with that, let's go ahead and begin. In number 1, what I want to do is I want to write down the slope-intercept form using the fact that I have a slope of -1/2 and a y-intercept of -3. So I'm going to start with a blank equation, which is that. And what's going to happen is actually quite simple. All that's going to happen is I'm going to take my slope, drop it in there, and I'm going to take my y-intercept, drop it in there, and rewrite this with those values in place. So the slope-intercept form is y equals -1/2 x minus 3. It's not necessary to write plus -3. You could if you want, but simple -3 would do just fine. I often get asked, Mr., would this -1/2 be any different if the negative were on the 2 instead of the 1? The answer to this question is the only difference that you would have is in how it looks and also in how it's telling you to move along the line. Just to illustrate my point, -1/2 or -1/2 versus 1/2 means simply this. If you were to go with the first case, which is this here, case 1, this negative being on the 1 simply means that you would, from whatever point you're starting with, you would then move down 1 unit, and then the 2 means you would move to the right 2 units. But if you go with case number 2, what this means is the 1 being positive means you would go up 1 unit, and the 2 being negative means that you would then go 2 units to the left. Okay? But that's the only difference. It's just the movement, again, which is where the M comes from. But other than that, in terms of comparing the value of negative 1 over 2 with the value of 1 over negative 2, they are completely identical. Because if I were to divide these by entering them into a calculator, what I would get is the value of this is simply negative 0.5, and guess what? So is this, negative 0.5. There's absolutely no difference in the actual value. Okay, all right, let's go ahead and move on. Number 2, write the slope-intercept form of the equation of each line. Well, there's only one such equation that we have to work with here. So again, the key being our focus is slope-intercept form. And so what we want to do is we want to eventually get this to be in this form. Okay, now one thing that you should notice is whenever you have slope-intercept form, the y is always isolated on one side. And so when I look at this equation here, I can see that that is clearly not the case. My x and y are sharing the left side together, and we don't want that. So what we want to do is we want to focus on moving things around so that we can begin to isolate the y, which is sitting currently right there. Okay, so what you want to start with is moving the x term to the other side. So this being a 1x, I will simply do the inverse, so negative 1x. I'll put it over here, negative 1x. And these two eliminate. And what that leaves me with is 4y is equal to. Now, I want to put the negative 1x first. You could put it last after the 20 if you want, but the reason I want to put it first is because I'm trying to follow this order, mx and then plus b. The truth is, if you really know your stuff, it doesn't matter if it's at the beginning or at the end, if it's mx plus b or b plus mx. They mean the same thing. Just make sure the sign stays with the right number. So moving on, negative 1x, my 20 is positive, so plus 20. And then my last step to isolate the y would be to detach the 4 from the y. And so because this involves multiplication here, I'm therefore going to divide by 4. That's the inverse operation. So dividing by 4, and I have to do it everywhere to maintain the equality of everything. So 4 divided by 4 is 1. There's my y by itself. Negative 1x over 4 simply becomes negative 1 over 4x. And remember, that negative could be on the 4, it could be on the 1, doesn't matter. 20 divided by 4 is 5. And just like that, that's slope-intercept form. So you can see there is a good match to that form there. And I'm going to take this a little step further to say that the slope here will be negative 1 over 4. That's our slope. And our y-intercept is positive 5. Okay, which once again you want to think of as 0, 5. All right, let's move on to number 3. So here I need to write the slope-intercept form of this line. When you have a graph, you want to keep in mind, if slope-intercept form is your ultimate goal, keep in mind the two things that are most important in order to complete this equation, which once again are the slope and your y-intercept. And also remember that the letter b, you want to think of this as beginning, a place to begin. And so because our beginning point is always going to be 0, y, we want to look for the y value. So we want to go to this blue line here, and we want to look for where the line intersects the y-axis, and it happens right there. So this right here is our y-intercept. That's our golden number, and it's at 0, 2. But I really just need the 2 part. That's all I need. So I'm going to plug this in, and so far what I have is the following. I have y equals mx and then plus 2. Okay, now to get my slope, I need to grab another point from this line, and I want to make sure to grab a point that is at a nice corner of one of these square units. So if I were to go for something like this, that would be a bad idea since I don't know exactly where that is. So nothing like that. This looks pretty good to me though. And so I'm going to identify this as 2, -1. Now you could get the slope by counting square units, but I like to always calculate it because I think it's good practice overall for other things. So we're going to go ahead and calculate the slope. The slope is our change in y over change in x. Okay, and so if we look at our y's changed from 2 to -1. So 2 changed into -1, and our x's changed going in the same direction. Our x's changed from 0 to +2. So 0 changed to a 2, and then just simplifying everything, we get +3 over -2. Okay, and just to give you a clear sense of what this means is that to go from one point to the next, you would have to go, pardon me, this should be up. You would go up 3 units. So up 3 units, and then 2 units to the left. Okay, so in other words, 1, 2, 3, and then 1, 2 to the left. All right. So now that we have our slope and we now have our y-intercept, we can finally finish this up and get the answer to everything. So finally, we're going to have y is equal to 3 over -2x and then +2. And that is the end. Okay, let's move on. Oh, one thing I want to say before I do move on is that if you're pressed for time, if you're taking a test, quiz, or if you're doing homework and your teacher does not require you to calculate the slope, then just go ahead and count the squares, get the equation done, and move on to something else. But I always think that calculating is good practice overall, just for understanding the concept of slope and which ties into rate of change. All right, let's move on. So let's see. Our last question is right here. So write the slope-intercept form of the equation of the line through the given points. Now here we have no graph, we have no table, we don't have anything except for 2 ordered pairs, each of which represents 2 points on a graph that we could make when we're done with this thing. So once again, if my goal is slope-intercept form, then I need to be aware of the things that I need. So I need this, my slope, I need that, my y-intercept. When I look at these 2 points, or these 2 ordered pairs, I want to see if one of them represents my y-intercept, because that is the place where I should begin if I have information to plug in there. And I know that the y-intercept is always going to be of the form 0, y, as I've said earlier. So I want to look to see if one of these ordered pairs takes on that form, and it turns out that it's this one over here. So this 0, 3, this is my y-intercept. Okay, and so all I need from that is the 3 part. So what I'm going to do is take that and plug it in. So far I have y is equal to mx plus 3, okay, because my 3 is positive. All right, so now I can check this off, check, and all I need is my slope. And in this case, I really have only one option. I need to calculate the slope. There is no other option to count squares because we don't have a graph to look at. So I'm going to calculate the slope. The slope is equal to the change in y over the change in x. And if I plug in my numbers, if I call this my second x and I call this one my first y, again, the order doesn't, my second y, The order doesn't matter, whether it's x1, y1 or x2, y2, doesn't matter. Just pick some place to start. So my 5 becomes a 3. 5 changes to a 3. Going in the same direction, -4 changes to a 0. And now simplifying this, I get 2 over -4, which reduces to -1/2. And notice I put the negative at the top, but based on what I said earlier, doesn't matter if it's at the top or in the denominator. So now this is going to go here, right in there. And when I replace it, I finish it. So finally, what I get is y is equal to -1/2 x plus 3. And that, my friends, is the end. So I hope this video helped you better understand how to write slope-intercept form based on different types of given information. If there is a comment that you wish to leave, please make it constructive. I always like to make sure that my videos are as clear as possible, but I'm open to suggestions. And as always, thanks for taking the time to watch. Bye-bye.